Today we're going to be starting our Unit 2B, which is on the equations of parallel and perpendicular lines. And while it's fairly similar to Unit 2 that we just tested on, we wanted to separate out this unit just because it focuses more on graphically how you determine if lines are parallel and perpendicular. So we're over the next week going to be talking about how you determine if lines are parallel and perpendicular and how you write the equations of lines that are parallel or perpendicular. Today we're just going to be doing some review on slope and how to determine if a line's slope determines if lines are parallel or perpendicular to each other. It's a very short unit. The test is next Friday, September 8th, and it's all found in 2.4 in your textbook. So if you ever need to get some extra resources, you can check there, 2.4. Okay, so first thing we need to do is just review what slope is and how to determine if it's positive, negative, zero, or undefined. I added a little video on today's folder in Schoology, which is Slope Dude, and Slope Dude is just a silly way to remind yourself of the different kinds of slope that you can have, but slope is just the change in the y values, the change in the vertical distance compared to the change in the horizontal distance. So if I wanted to classify this kind of slope, the y's are going up, so they're increasing, and the x's are also increasing, if you're thinking about it on a coordinate plane. So that first one we would classify as having positive slope. As you're reading the graph left to right, it would look like it's going uphill. Versus that next diagram, the y's are increasing, but the x's are decreasing. So when you have a positive over a negative, change in y is positive, the change in x is negative. This is a negative slope. You can also look at it in the reverse direction. The y's are decreasing, but the x are increasing. That is also going to give you a negative slope. So negative slope looks like you're going downhill. If it's completely flat, we call this zero slope. Zero slope. Slope Dude says that if he was skiing on this would be zero fun. So that's his silly way of remembering it. And then if it's completely vertical, completely up and down, we call this kind of slope undefined. So those are your two unique cases. Completely horizontal is zero slope, completely vertical is undefined. In order to determine if lines are parallel or perpendicular, you need to be able to find the slope when you're either given the graph of a line or given 2 points that are on the line. When you're given a graph, the easiest thing for you to do is find the rise over the run. The rise is the change in the y's, change in the y values, over the change in the x values. Now, when you're using a graph to find slope, it's important that you use clear points. When I say use clear points, I mean points that are going through, like places where the line is going through the corner of a square. So I will make note of that when we look at a graph in just a moment. So when you're given a graph, just find the rise over the run. If you aren't given a graph, instead you're given two ordered pairs, you'll be given like x1, y1, and x2, y2. That's just identifying two different points, and you want to find the slope between them. It's the same idea. It's the change in the y's over the change in the x's. Change makes us think subtraction. So you take y2 and you subtract y1. You find the change in your x's, x2 minus x1. Or you could, it doesn't matter which one's the first point and which one's the second point. You can just write it as y1 minus y2 over x1 minus x2. The order doesn't matter as long as you keep that order consistent. The numerator and denominator do matter. The y's are in the numerator, the x's are in the denominator. So it's the rise, change in y's, over the change in x's. All right, so getting more into parallel lines, we're going to talk first about parallel lines and then perpendicular lines. We're going to check and see if lines K and N are parallel. So when I'm looking at line K right here, if I want to find the slope of line K, if I want to determine if lines are parallel, the main thing you're worried about is their slope. So I'm going to look at this line K, and I'm going to find 2 points that go through the corners of squares. So -2, 2 is one, and 2, -3 is one. If you like doing more arithmetic style stuff, you could use the points -2, 2 and the points 2, -3 and find the slope. Or if you're given a graph, you can find the rise over the run. So we're going up 1, 2, 3, 4, 5, and we're running 1, 2, 3, 4 to the left. So this is a slope of 5 over -4. So I'm going to make a little note that the slope is equal to 5 over -4. By the way, for whatever reason, I know slope doesn't have a m in it, but whenever we're referring to slope in math, we use the variable m. So the slope of line K is 5 over -4. And we want to see if it's parallel to line N. Line N is right here. So I'm going to find 2 points that go through the corners of squares again. So here's one, and here's one. And I'm going to find the rise, 1, 2, 3, 4, over the run, 1, 2, 3, to get to that point. So it's a slope of 4 over -3. Went up 4 and went to the left 3, so we would say it's a slope of -4/3. Now, you'll notice that these two slopes are not equal, so we would say that the lines are not parallel. So they are not parallel. Because the slopes are not equal. In order for two lines to have to be parallel, their slopes have to be completely the same. So even though those kind of look parallel, they look like they wouldn't intersect ever. They actually, in fact, would eventually. Let's do the same thing with M and Q. So we're going to check out M. M is right here. And we're going to compare it to the slope of Q. So M, I'm going to look for points that go through the corners of squares. So we've got these two. And remember, you're counting up and then over, or rise over run. So we go up 1. So that's a rise of +1. And then we run 1, 2, 3. Since we're going right, that's +3. So our slope of that line, line M, would be +1/3. Q down here, if we want to find the slope of Q, again, you're going to find points that go through the corners of squares. So this guy and this guy look like they're good candidates. And we're going to find the rise, 1, 2. So we went up 2. And we're going to find the run, 1, 2, 3, 4, 5. We went to the right 5, so that's +5. So our slope of Q is 2/5. Again, you'll notice that these are not equal to each other. So we could say the exact same thing as before. Those lines are not parallel because the slopes are not equal to each other. So none of those lines were parallel to each other. Okay, so we've just talked about this, but parallel lines are two non-vertical lines. They're parallel if and only if their slopes are congruent to each other. Their slopes have to be completely the same. Any two vertical lines are automatically parallel. So vertical, it's like two undefined slopes. They're automatically parallel. Perpendicular lines is what we're going to get into next. Perpendicular lines are two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Just to remind yourself, parallel lines never intersect. Perpendicular lines intersect, and when they intersect at a 90-degree angle. A vertical line and a horizontal line are always perpendicular to each other. So vertical, horizontal, they're always going to intersect at a 90-degree angle. So a slope of 0 and an undefined slope are always perpendicular. If you want to determine if two slopes are perpendicular, all you have to do is change the sign and flip the fraction. We call those opposite reciprocals. So for example, if one line had a slope of 3/4 and we wanted to find a slope that is perpendicular to that, it would have to have a different sign, so it would have to be negative, and we'd flip that fraction over, 4/3. If you multiply 3/4 and -4/3, you're going to get -1. So one easy way to check yourself, multiply those two slopes together and it should equal -1. 2, if we want to find the opposite reciprocal of that, imagine that 2, since it's a whole number, is sitting over 1. So its opposite reciprocal would be negative 1/2. The opposite reciprocal, or the perpendicular slope of negative 7/8 would have to be positive, and then you flip 7/8 over to get 8/7. 1, just like 2, is sitting over 1. So the opposite reciprocal of that would be negative. You flip 1 over, and you still get negative 1. If you want to check yourself there, 1 times negative 1 is negative 1, which proves that they are perpendicular slopes. 0, a slope of 0 is a completely horizontal line. So it's going to be perpendicular to a completely vertical line, which has an undefined slope. Or you can think about it as this is 0 over 1. So a completely perpendicular slope would be 1 over 0, which we can just write as undefined. Flip it on over to the back and we'll keep chatting about perpendicular lines. We're going to check and see if J and K are perpendicular to each other. So to determine if they're perpendicular, we have to find their slopes. So J is right here. Again, if you're finding the slope from a graph, you need to find 2 points to go through the corners of squares. So here's a point, here's a point. Let's find the rise over the run. So we go up 1, 2, 3. So that's a rise of 3 and a run of 2 to the left. So we would say our slope is negative 3 over 2. So line J has a slope of negative 3 over 2. K, on the other hand, up here, let's find its slope. Find 2 points that go through the corners of squares. Find the rise, 2, and the run, 1, 2, 3 to the right is positive 3. So that has a slope of 2/3. Now, take a look at these two numbers. If you multiply them together, negative 3/2 times 2/3, you're going to get negative 6 over 6, which is negative 1. Or you can check the signs, make sure they're opposite. So one's positive, the other's negative, and then those fractions were flipped over. So these we can confirm are perpendicular. Which means when they intersect each other right here, they create a right angle. That's all perpendicular means. Okay, I'm going to give you a moment to take a look at H and L. H and L. H is right here, and L is right here. We want to find the slopes of those. So find the rise over the run. I'm going to find H's slope first. And it's kind of tricky with H because there's no other points that go through the corners of squares. So instead, I'm going to start with L, and I'm going to find the slope of L. And we'll talk through this in a minute. So we have 1 point here, another point here. Goes through a corner of a square, so we know the exact location of it. Let's find the slope. We go up 1, 2, 3, 4, 5. So that's a rise of positive 5 and a run of 1, 2. Went to the right 2, so that's a slope for L of 5 over 2. Now, if line H is perpendicular to line L, it needs to have a slope of negative, flip the fraction over, 2 over 5. So we want to see if the slope is negative 2 over 5. So we have 1 point here where they intersect. Let's see if it has a slope of negative 2/5. So we can go up 1, 2, and run 1, 2, 3, 4, 5. The line is obviously not there. So the slopes do not have opposite reciprocals. You could also go in the other direction if you wanted to. Sorry. We got a point here. Sorry. Got a point here. If we went down 1, 2, and then over 1, 2, 3, 4, 5, the line is not eventually going to reach over there. So we can say that they do not have opposite reciprocal slopes. They are not perpendicular. Last ones we're going to check are K and M. We're going to determine if K and M are perpendicular to each other. So K is right here. Let's find the slope of K. I think we already found the slope, actually. It was up 1, 2 over 1, 2, 3. So K, we already found at the top, had a slope of 2/3. And M. M is right here. Find 2 points to go through the corners of squares, so they're nice and precise. Here's one, here's one. The rise is 1, 2, 3, 4. The run is 1. Went up 4 and to the left 1, so it's a slope of -4. So are those opposite reciprocals? Obviously not, so we would say they are not perpendicular. Those lines, even though they kind of look like it, they do not intersect at a right angle. All right, let's check out number 6. We're given 4 sets of points, and we want to find the value of x so that AB is parallel to CD. So remember, if lines are parallel to each other, they have to have the same slope. So we want whatever x is, we want to be able to plug in a value for x so that those lines have the same slope. Well, in order to find out what that slope is, we need to find the slope of AB. So I'm going to find the slope of AB. When you're given a set of ordered pairs and you want to find the slope, you take the y's and you determine the order that you want to subtract them, but you subtract those first. So I'm going to do 2 minus -12. So I did the second point minus the first point. If I do that, then my denominator, I have to do the second point minus the first point. So -2 minus -9. And then let's simplify that out. 2 minus -12 is 14. -2 plus 9 is 7. So we know that we want the slope to be 2. So we're trying to figure out now what we can put in place of x so that when we find the slope of CD, it also has a slope of 2. Let's give this a shot. Let's start by plugging in what we know. So we know so far the slope of CD is going to be the change in the y's. So we can do -2 minus 6 over the change in the x's, -5 minus, we don't know that x value. But we do know that we want the slopes to be parallel. So we do know that we want it to be 2 so that it can have the same slope as AB. Now you've just got a little equation that we need to solve. Block this off. -2 minus 6 gives us -8 over -5 minus x equals 2. Imagine that this 2 is sitting over 1, and we can just simply cross multiply. -8 times 1 is -8. 2 times -5 minus x. I'm going to wrap that -5 minus x in parentheses so I can distribute it. So I'm just cross multiplying here to solve for x. So we'd have -8 equals -10 minus 2x. We'd get 2x equals -10 plus 8, -2. So we should get that x is equal to -1. If we have an x value of -1, then the lines should be parallel to each other. You can double check yourself, go back up here, find the change in the y's over the change in the x's. So 6 minus -2 over -1 minus -5 would give us 8 over 4, which gives us a slope of 2, which is exactly what we wanted it to be. So your final answer there would be x equals -1. Similarly, on number 7, we're trying to figure out how we can make what value we need to make y so that we can make the lines perpendicular to each other. So we're going to start out, we want to find first the slope of CD, and we can find the slope of CD because we're given both the ordered pairs. So let's do 16 minus 11, the change in the y's, over the change in the x's, -5 minus -8. 16 minus 11 gives us 5. Negative 5 minus negative 8 gives us 3. So that's the slope of CD. If we want these two lines to be perpendicular to each other, we want them to be opposite reciprocals. So we need to change the sign, and we need to flip the fraction. So we want our desired slope of line AB to be negative, and then we need to flip this over, 3/5. So whenever we find our little equation for AB, we're going to set it equal to negative 3/5 because that's what we want our slope to be. So AB, let's plug in what we know. Let's do the change in the y's. So y minus 2 over the change in the x's, negative 1 minus 9. We want that to equal negative 3 over 5. Now we've just got to solve our equation. So I'm going to carry this up here. We'd have y minus 2 over negative 10 is equal to negative 3 over 5. Similar to the problem last time, if we want to solve for y, I think the easiest way is just to cross multiply. Negative 10 times negative 3 is 30. Set it equal to 5 times y minus 2. So we get 30 equals 5y minus 10. 5y equals 40. So y needs to equal 8. If y equals 8, then the two lines will be perpendicular to each other. Again, you can always check yourself by plugging that 8 back in, finding the slope, and make sure it's the opposite reciprocal of line CD's slope. All right, let's check out our last one, which is a little Marty mistake maker, and then we should be good to go. Devin said that line AB and line CD for all these points are parallel. Explain and correct Devin's error. So to find the slope of AB, he was looking at AB right here. He did 3 minus 0. That's good. That's the change in the y's. And then he did 2 minus negative 2. And he found the slope is 3/4. So far, that's looking pretty good to me. Then he found the slope of CD. So to find the slope of CD, he went over here and he did, what does it say? Negative 1 minus negative 4. That's totally fine to subtract in that order. But if he does that, then he needs to keep that order consistent when he finds the difference of the x's. And it looks like he flip-flopped the order. So hopefully you're catching on here that he should have done negative 1 minus negative 4, totally fine. But if he does it in that order, he should have had a denominator of 1 minus 5. 1 minus negative 4 gives us 3 over negative 4. And then we would take a look at these slopes. And are these slopes equal to each other? No, we would say that they are now not parallel. So common error right there is just making sure that you keep your order consistent when you are finding the difference in your y's and your difference in your x's. You have a little homework assignment to practice parallel and perpendicular line slopes, and I'll see y'all on Tuesday. Have a good weekend.